Well, it's 11:15. I want to welcome Wayne from Rochester, New York. The session is entitled Optimizing Algorithms in Applesoft BASIC. Thanks, Wayne. Take it away.
Well, hello, everybody. I just thought I'd give you a quick overview of who I am. I've been hanging around for a long time, and my interests were mainly in the Apple II E and C space, because that's what I had growing up. There was a 2GS at work, and I got to use one. But I know that people tend to concentrate on the 2GS now, but I was always more of an Apple IIe person. A couple of years ago, I believe it was Sean who gave me an Apple IIc Plus. Earlier this year, I bought the VGA adapter for that, and it got me really excited. So with a friend of mine, we started talking about stuff that we could work on, and eventually he brought in a simple algorithm that we decided we would start playing with in BASIC and see what we could do. So let me show you that real quick here. And I know the picture's kind of bad because I took it from the book that you brought it in on, but basically it's called a conic circle. People may have seen it before. It's real simple. You take two corners and where you're gonna center on, and then you run and calculate whether or not you should plot a point on each one of the XY. So you can also use colors to do some other, prettiness to it, but because of the way that the high-res graphics work on the Apple, I decided to kind of skip out on that. So this is the basic algorithm, and then we just decided to go ahead and implement it straight from how it was. So our first attempt was, can you all see the emulator?
Yeah. Oh, yeah. Great.
Okay. Our first attempt was this, right? And this is, if you can see, it's basically Windows 7 likes to change your window size all the time. If you can see, it's basically exactly the pseudocode translated right into BASIC. So before I got it running on the 2C Plus, I actually ran it in the emulator, and I had it on the fastest, which on my machine turns out to be like 100 and something megahertz. So when I ran it and just did a simple plot, it was fairly performant. Okay. So this takes like 45 seconds to a minute. I'm not going to run the whole thing. I'm just going to stop it out now. And now we're getting ready to move it over to the 2C Plus. So I know the 2C Plus runs at 4 megahertz, but there is no real 4 megahertz setting on the Apple II Win that I've been able to find, and I haven't gone into the code yet to change it so I can actually peg it at 4. So I just decided to go with the authentic machine and just run it to see what type of speed we'd get there. So I did the exact same numbers again and started to run it, and noticed that it was excruciating. Okay? And I said, we started talking, we said, look, there's no way it's that slow, or there's no way we can't do it faster than that, because this has been done, this has been implemented many, many, many times. I believe it was in a Popular Science article or a Scientific America article back in the 70s or early 80s. So it's not like we were doing anything that needed a super fast new computer. So we started to look at what was causing the problems. I wish I knew a shortcut to do text and home at the same time. I always mess that up. So we started testing, and the first, we did just a test of a loop, because while we're working on this, I talked to Michael Mahone, who made the Applesoft, and on his website he talks about the speed of some operations in assembly on the Apple II, and I wasn't really sure where he was getting that, if he knew the timings or if he had some way of doing it. And basically he told me he was just taking his loops, expanding it out to a large enough where there would be large number of seconds in between each run as he changed things, and then just basically used a stopwatch. So that's what I started doing. So if you see this test, oh, hold on. It's just really what we're doing, which is actually I blew it out to quite a lot, and I ran that, and let me just tell you, this takes an extremely long time. It doesn't finish. So I decided to change it. Right, to just what I'm using, to 279 to 160, and next, and run that. Now, on the 1 megahertz emulator, it takes a minute and 7 seconds. Now, we can sit here and watch, or I can show you how I did this. So to get these times, I decided to use a screen capture program called Jing, which is for the Mac and for Windows. And it basically just lets you record up to 5 minutes of a screen capture, and then, can you see it here? Just want to make sure. Let's switch over to something else.
Yep.
Hello?
Yes.
Okay. So what I did is I ran it, and using the timer on the bottom, I can see how long this took. So you can see that I started it at 5 seconds. We'll fast forward, and it finishes at 1 minute 12. Okay? And you subtract out the 5, and that brings you down to 107, 1 minute 7 seconds. All right? And I remember things from growing up, and books that I've read, that there were ways to speed up loops. So I brought in the next one, which was I can't remember the stuff. Load, simple, loop, test 1, and see, this time I just got rid of the index variables and next, and ran the loop again, and it drops it down to 53 seconds. Okay, so removing the index variables does make a substantial change, because that loop runs 44,640 times, and we managed to shave almost 10 seconds, 14 seconds off of the run.
You also removed a line.
Hello?
You also removed a line.
Which is nice.
You say you used to go to 40 for the 2 next.
You got to talk a little louder, I'm sorry.
You combined the 2 necks onto 1 line?
Yes, correct, I also did that. Yep.
Which might have been.
Yes, I did kind of cheat and do 2 changes at once. But I knew that this was going to be one of the better ways to increase loop speed. So I just went ahead and did that. I have videos of all the changes that I made, so if anyone's interested in looking at that in the future. So then I decided to do just some testing. I wasn't sure. And so I actually used a book that probably a lot of you have. which is, well, I'm just going to switch on the video real quick. And wouldn't it be amazing if a company actually did this today, which is the Applesoft BASIC Programmer's Reference Manual. And in here, there's a chapter, well, there's a couple pages on how to speed up your programs. There's a section on saving space and one on saving time. And one of the things it said to do was, since variables on the variable stack are allocated as they're used, or they're placed on the stack as they're used, you can make some speed increases by moving your most used variable and have it allocated first, which is what I did. Since J, right, is used first, I put it there, and then I, and then one of the things I also was trying is that I couldn't remember if I had read that using a variable for your end of a loop would speed things up or not. So I just decided to try that. And when I ran that, I got 52 seconds. So about a second faster by moving the variables around. And again, on 46,000 calculations, well, 46,000 runs, which ends up being almost 270,000 calculations, I think, which we'll see later on. That could make a significant difference in the 10 to 15 second space. So then I wasn't real sure if putting the endpoint of my for loops in variables was speeding things up or not. So I went with another test. And you can see here I got rid of those and did the exact same test. And
Actually, we can't see here. We're looking at you.
52 seconds.
Yeah,
We
we're
can't
actually
see the
looking at
screen.
you right now.
Oh, I'm so sorry. So
Not that
sorry.
that's not enjoyable.
All right. Yeah, I'm not half as interesting as an apple would be, so.
Certainly not when you're describing code.
Yes, I apologize for that. Thank you for pointing it out. And so you can see here.
No, we still can't.
We still see you.
I got you. I'm sorry?
We're still
can-
seeing you.
Oh, really? Oh, here we go. There we go.
Yeah.
Is that better?
Yes.
Yeah.
Much
All
better.
right, after you get the box around the app, you have to hit start, just in case anyone's curious. Makes things a little easier there. So this is where I was trying the up here on the first listings where I tried to use the end variables as well as put them in the right order of how often they be used, and then down here is when I redid the test by getting rid of the end of the loop as variables and also ran the test, and I got the exact same speed for both of those. In case you're curious, on 1 megahertz it adds up to 852 loop iterations of the inner loop per second. Okay? So then it was time to start looking at the program. So let's go back to the original and see where it could possibly be optimized. And you can see I was using the power function, okay, or exponent function, if you will, and I thought I had read somewhere that that was pretty slow. So I decided to do some testing on that. And sorry, should have wrote. I wrote down the names of the tests, but I didn't write down the file name. So if you see this, all I did was just raise the J to a power and assign it to a variable. Now when I ran this on the 1 megahertz, at 20 minutes it hadn't finished yet. Okay? So I knew that that was definitely somewhere where we could increase some speed. So then I brought in, since we all know that a square is pretty easy, I just made it J times J. And when you run that on the 1 megahertz, you get it down to 3 minutes and 16 seconds. And since the loop takes 52 seconds on its own, the whole thing is 2 minutes and 24 seconds for a total of 182, multiplication operations every second. Now, that's a pretty good, I mean, that's a decent speed. But as we started to go on, we actually start hitting a point where some of the functions won't finish in the 5 minutes, in under 5 minutes. So I decided that it was time to switch over to 2 megahertz. So I brought it over to 2 megahertz, and I reran this and got it down to 1 minute and 11 seconds, down from 2 minutes and 24 seconds. And the loop, which I also reran, became 27 seconds. So if you just look real quick here, you can see that we're running about 597 operations a second, which for 2 megahertz is not too bad. And I didn't see any other way to optimize it. So then part of the algorithm that we're playing with actually needs modulus. And we all know that one of the big missing functions from Applesoft BASIC compared to any other Microsoft BASIC of the time, and yes, I'll call it a Microsoft BASIC, because it really was modulus. It's just missing it. So there are some algorithms are posted to do modulus all over the place, and I chose one. And that's simple. It's just to take the integer portion of a number divided by 2 and then multiply it by 2. Okay? So you're either going to get a 0 or a 1. Right? Because, right. Is that right?
No, you have to subtract that from the original.
Yes, you're right. And this would explain a problem. So I've been doing this wrong the whole time. This is it, right? Oh, I tried.
Minus.
Wow. Well, this is going to change some of my runs, so now we can start looking at the runs. And if we run that, it used to take 3 minutes and 12 seconds at 2 megahertz. I bet you it's going to take a little bit longer than that now. And I don't have the timer going. Hold on. That's very embarrassing. Thank you for pointing that out, though. All right, so I started it right on the 5-second mark. So, while this is running, I just want to see if anyone else knows of any other just looped optimizations that I possibly missed. I only have access to a couple years of nibbles and a couple of different books, and that was about as much as I could find in what I was doing.
You could do this with a single loop.
If you expand
Single loop?
If you expand your inner loop to 160 states.
Well, all right. You'll start to see later why that stops being a possibility.
What things do you actually need to square?
I need to square 2 sets of. Hold on. Let me pull that up. Let me pull that up real quick. That's right.
And one of them is just being incremented by 1 each time through the loop?
Yeah,
So you can add successive odd numbers and you'll keep generating the next square.
That's a neat trick.
help me with that again?
If you're generating squares of successive integers, you just
Right.
add the next odd number and you get the next square. Cheaper than a multiply.
Right. All right, I'm gonna put that down.
And also, so x depends only on I, and y depends only on j.
Well, yeah.
So
Yep.
you can pull the thing that depends only on I outside the j loop,
Yeah, that's done a little bit later on. Yep.
including the computation of the square.
Yep. Yep. Did that a little bit later on. Yep.
So it also could be done with the odd number trick.
All right.
Sorry, it sounded like you were looking for ideas, but apparently you've got them already.
Oh no, I know. It's just while I was doing this, I wanted to see some just kind of basically, since it has to run for 3 minutes, I was trying to get people involved here.
You know, if you were here, you could just do it in Microsoft.
How about shots of the cat?
Yeah,
Shouldn't
let's
shoot the
see.
cat, they get mad.
If you have a laser, you can play with the cat too.
One has optimizer.
So we're already at 3 minutes and 12 seconds, which is longer than it took before. So. I wonder when I mistyped, how long ago I mistyped the modulus algorithm. Probably 3 months ago when I started this, right? So now we're at, there we go. So 3 minutes and 50 minus the 5 seconds. So that brings it to 3 minutes and 45 minus the 27 for the outer loop, 3 minutes and 18 seconds. So that then brings us down to 198, so 46,400, no, 46,000, no, sorry, 44,640 divided by 198 brings us to 225.45 operations a second here. So that is that's not that bad actually.
Yeah, it just one subtract.
Yeah. Thank you very much. I've been messing that up for quite a while. So that brought us down to 225, which it's not a substantial loss, but yes, it definitely is a change here. So then my next thing was that I knew when I was younger, I never used any of the I never used the function used functions inside of BASIC, those simple functions with the single variable. So I decided to try one of those out using the mod. So now I just need to make a quick change here. And when you run this, well, it used to be a lot slower. It probably still is a lot slower. It used to take, oh, sorry, put you back over there. Used to do it like this. Someone's cell phone is buzzing over there.
I think our fan just started up.
Yeah, air conditioning.
All right, and so when you run this, before I made the change to subtract, it was showing at the function. It was showing a 4-minute 28, right, for a total of 185. Now, if we run, it's probably going to go over our 5 minutes, and it's probably not worth showing right now. But needless to say, it's substantially slower, which to me was a little bit odd. I guess I had assumed that the function would have tokenized things into memory, so you wouldn't have to retokenize it each time, but apparently it doesn't work that way.
It also has to do a variable lookup for the function name.
Right. So it was surprising to me that that wasn't faster. Very surprising. But what are you going to do? So then I knew that obviously that we could just start optimizing loops. So I just ran a couple of quick tests. One's called the bad loop. And that is where we basically square and then multiply by j. I mean, this is just to see what the speed difference is. It's not actually used in our. It's not exactly how it's used in the algorithm, but it gives us a good idea. And running this actually takes 2 minutes and 55 seconds, which when you reduce the loop itself comes to 2 minutes 28, or gives you 180 calculations every second, and that's kind of slow. And when I calculations mean to complete our calculation, not pure calculations a second like they talk about normally. So then, of course, this is a very easy to optimize the loop, and we do that on better loop. So here we're pulling it out, so we're only calculating XX as many times as is needed, and then obviously doing the XJ only thing. And this decreases our time to a minute and 14 seconds to give us a total of 603 major calculations every second. So then, I need to run that. So then, we start using all this stuff that we had learned with, optimizing variable lookups and everything. We decided to go back to our fractal program. Which isn't really a fractal, as it has no z, as I found out later. But it's just easier to say that, and that's what I had saved that as, and just never changed it after that. And to start doing some optimization, right? And you see that we actually have that wrong even all the way back here, which is just really sad. I feel just. So we start doing some optimization. So our next test was to do some work and make it to this state. And at this state, I hadn't done, actually, I guess this had happened before I had realized that the functions didn't speed things up. And you see that we still have, and for some reason I have the function in there twice. This was actually pretty fast. As you can see on the 2 megahertz, if we do our initial one, 0, 0, and 10.5.
Thanks for mod.
In the function, you've got an equal sign in place of a minus.
Thank you, because that's still wrong.
That was true on the top here too.
Change the top one. Alrighty.
Okay. So we ran this, and as you can see, I mean, on the 2 megahertz is substantially faster than what we started with. Right? So, I just want to, just to do the comparison, we'll do see it, just substantially faster here, right? So then, about done here. This was the final, which is to get rid of the function and go from there. But now we have to, of course, fix my dumbness. Okay, and we pulled out all of the portions that just don't, that can be pre-calculated. All right, optimized the variables for the run, and kind of went from there. And I see that there's still a couple of things sneaking in here. I left because I was experimenting. I'll talk about something in a second here, but I still, because it didn't really decrease the speed at all, I left the variables for the end of the loops in here. Part of it because for some reason if I change it to 280, even though there's supposed to be 280 columns, I actually get an error, which I've never quite understood. And
column 0, I think.
so if we run that, there's a very, very small perceptible speed increase over the previous, but it's there.
I have a question.
Yes.
Before you made the change, this was all
Yes.
this was all just inverted, right?
Yes.
That's because that you actually were computing mod 2, except it was the not of mod 2.
Yes. Yep. Yeah. Well, I guess that, but that would be a less expensive operation, right?
Yes, it would be.
Yeah. Yeah.
Actually, I don't remember whether floating compare does a subtract or a compare. It might just do a subtract. Might be the same.
Oh yeah. And so I've done. I've looked through. You know, someone did the disassembly of the Applesoft BASIC and has it published online. I think that came from the Robert Wagner. Was it in his? No,
Yeah,
or
the source
was it in Orca?
It was Robert Wagner. It was at
Yeah.
Merlin Pro.
Yep, and so I did some looking in that, but as never being an assembly programmer, my understanding of things was a little less than complete. But I am going to experiment with the subtraction and not subtraction and using the alternate on the if statement. So. So as you can see, so this is what we have, and it actually we'll speed it all the way up just so I can show you now what this actually shows. Because it's actually quite fun, right? So that's for 10.5, and then there's some, so the zeros is where it starts. So you can see right now it starts in the middle of that circle. So if we move those up to 15, it would be like starting 15 pixels in and 15 pixels down, so it should be around here. And we'll still do the 10.5. Okay. All right, and then you can do it, we'll leave it at zeros, and we'll go with some other cool, like at the 5.6, there's some, I just think these are so interesting to me. And doing it in Applesoft was a lot more fun than trying. I haven't actually done any graphics programming at all since I moved off the Apple. You know, in 1993 is my primary machine, which I still find rather amusing, because this was just so much more fun. And then there's another pretty interesting one here at, I think it was 2.56. No. So this is interesting. You kind of see how it's zooming in on it, right? And we'll bring it out real quick, out to about 50. Right, and then you wind up with very tiny circles.
Not on our screen.
Got to update still.
Okay. Let me know when you get that.
Doesn't seem to be doing
Okay,
it.
I don't think it's your
I think we're up with
You got it?
I think so. It hasn't
All
been
right.
fixed itself yet.
Change anything.
There it is. There it is. Okay.
Yeah. See, it's pretty dense. That's what it goes when you start to zoom out. And then you just do another one, like at the 21 space, and you get some pretty interesting. It's just, I find it so cool that there's these seemingly random, right? So it does like dark with a hole in it. Then I just find this totally intriguing. And I don't know if anyone's ever read any of the Stephen Wolfram stuff, but some of these are, you know, similar to the things that he found when he started doing all of his computational analysis. But it's pretty interesting. So that's what I've been playing with, and that's how I did some optimization, even though I had the algorithm wrong for the modulus there. And I guess now to flip it around, the question I have for you is that no matter what I did, I can't get rid of the text portion at the bottom when I do an HDR, right? It always leaves the text portion, and I thought, so, you know, I went through the Apple Basic book and it says do a HDR2, which does get rid of it, but then anything I plot, right, just never shows up.
So that's on your
Oh,
HDR one.
you're in 80 columns. If you get back to 40 columns, you'll see.
Control Q.
In line 50, you'll need to change that to an HDR2 as well.
Yeah.
So how do you get back to 40 then? I can't remember
Escape
this.
4.
To go back. Anyone? How do you go back?
Escape 4 will do it.
See? It's been too long.
Can change the code.
Line 50,
Line 50.
change that to HDR2.
And you also have to change your loop variable to go up to 191.
Yeah.
Each color equals 3.
Equals.
Oops, yeah, each color equals.
Oh, yeah, I see it. So if you're in 80 column mode, you can never get rid of the text then?
Well, HDR2 doesn't work. You can get rid of the text of the poke, or P rather.
You need to fix 1050 also. There you go, sorry.
Well, you may want to start at 0, not 1.
Yeah.
Yeah, because the first pixel column is 0. That's why you can only go to 279.
That's
All right.
Yeah.
Thank you. These are the things we
That's
forget.
need to be 191.
191.
Yep. Gotcha.
Does the other one stay 279?
Yeah,
Okay.
that's your horizontal.
Tell them if there's an error.
Ah, how beautiful. Thank you. Thank you very much. So that's what I've done. Any comments or questions or pointers on where else I can look to gain more speed? Because at 1 megahertz it's still pretty excruciating.
I'm not sure if it would help, but you could unroll your loop, and instead of incrementing by 1 each time, increment by however many calculations you've done. Right, so you do the calculation like 5 times, and then increment your loop. Do your loop step 5.
All right.
And a huge change would be to actually re-implement mod. So just go, essentially convert to an integer and look at the low bit. But that's not Applesoft. That would be a full machine language program.
You also mentioned you could poke to get the 80 columns without the text he was trying to get rid of.
Oh yeah, there's the full screen graphics poke would allow you to keep using just plain HDR and get rid of the text.
With 80 columns.
Yeah.
Oh, the full screen.
Right.
Yeah, that's the. Yeah, I have another book called Apple Subroutines, or Tips, Tricks, and Subroutines.
Do you have the Apple II reference manual?
The Applesoft BASIC reference manual?
No.
Or the Apple?
The machine.
No, I don't have the Apple II reference manual.
Let's see if there's that little.
We lost
That
the
little,
video.
that little picture.
Yeah, I was trying to get back on the. There we go.
So
So.
I thought it did a lookup for every line number, right? Don't you?
You do a
get some-
go-to.
With loops. Or with
Not for a 4. 4 stacks the
It
address.
does, these are on the side.
statement, yeah.
Okay.
Yeah, that's the
Well,
one
I-
organization that it has.
Okay.
So I do thank you for humoring me and looking at what I've been working on over the past 3 months, off and on, and thanks for the additional input on things that I can do to speed things up.
Do you have a website?
And then eventually I'd like to switch it up, start using this same algorithm to start experimenting with assembly programming on the Apple II, and perhaps even with Pascal programming as well, just to see the different speeds that can be achieved using the different languages. I looked through the old nibbles and see that there were, versions of Forth and some C-like languages, some of which I think are lost forever or are going to be difficult to find, but it would be interesting to experiment with all of those.
Do you have a website?
I do. I just started posting on it again. Well, let me let's see what can we do.
There's one other reference book that I would recommend. It's called The Big Tip Book for the Apple II, and it's by Beagle Brothers.
Okay.
Now it has all kinds of really nifty references for Applesoft BASIC, including how to manipulate the graphics screens.
All right. Yeah, I think, is that up on that Beagle Brothers site?
It's somewhere. I've seen it.
All right.
Let's see.
Yeah.
It's not gonna work.
Mark Simonson, who did our keynote, said that he was going to be contributing some more material to the site, the Beagle site.
So this is my website here, just warthurton.com. Is that too small? I bet you it is.
Arthurton.
Yeah. And I haven't done any Apple II posting yet. I was waiting to do this, and I'm going to start to, start to show people what I have been working on and what I've been finding. I even started to, how much more time do I have? Just because
We're actually over because we got lunch now.
Okay, well, just really quickly, what I do to switch back and forth between my physical machine and my virtualized is I actually have been using that A2DT Pro, and I actually have a 3.5-inch disk image.
Oh,
I'm going
ADT.
to push it back down to my physical 2C Plus. Do a bunch of experimenting, and then I sync it back up. And I also have it synced on using Dropbox, so it goes when I run my Mac, and I want to run it on Sweet 16, I can. So it's been pretty cool to kind of keep that all in sync. Well, thanks again, everybody. I appreciate it.
Thank you.
Thank you.
It's been a really
See you next time.
You just dropped your pen.